Hi! Today we're going to learn about sequence convergence in calculus. Let's say we have a problem like this. Let's say we have the sequence a of n, and it goes from n is equal to 1 to infinity, and the sequence is 5n cubed plus 3n squared plus 2, all over 6n cubed plus 3n cubed plus n. And then we have the second sequence, which is a of n from n equals 1 to infinity of n cubed over e to the n power. And because these go to infinity, we have to find out whether they converge or diverge. And if they converge, what do they converge to? So let's take this first problem. We have 5n cubed plus 3n squared plus 2 over 6n cubed plus 3n cubed plus n. So the 6n cubed plus 3n cubed can just be written as 9n cubed. So let's change that. We have 9n cubed. 9n cubed. Now, how do we figure out if this converges or diverges and what it converges to, if it does converge? Well, if we look at this, we know that this is a rational equation. And we know that rational equations have asymptotes, and as they go to infinity, they approach some value. Or they don't, and we know the rules for if they do approach a value or not. So, to see whether they approach a value or not, we need to identify the dominant terms in both the numerator and the denominator. Now, the dominant term for a rational equation is the one that has the exponent the greatest, or the one which has the greatest exponent. The dominant term is also the one that grows the fastest. So, we can see that 2 is not the dominant term in the numerator. Now we're left with 5n cubed and 3n squared. So we know that 3n squared grows slower than 5n cubed. So that means that this is not the dominant term either. So that means that the dominant term is 5n cubed. In the denominator we have 9n cubed and n. Now we can see that n is not the dominant term, which leaves 9n cubed to be the dominant term. Now because in the numerator and the denominator we have the same power for n, that means that this rational equation converges to the numerator's coefficient over the denominator's coefficient, which equals 5 over n. So the answer to problem A, or the first problem, is that it converges to 5 over 9, not n, sorry. Now let's move on to the next problem. We have to find out if n cubed over e to the n converges. Now, how do we do this? We know this is not a rational equation. Well, we do know that n cubed grows slower than the exponential e to the n. So that means that as we approach infinity, so the other way to figure out if a sequence converges is to set the limit to infinity. So we have to say the limit as n goes to infinity of this, and if it converges, that's what it converges to. So this would be equal to, so figuring out whether this would be, if the sequence going to infinity would be equal to the limit as n goes to infinity of n cubed over e to the n. If we plug this in, we get the limit as n goes to infinity of infinity cubed over e to the infinity power. Now as we can see, the exponential we know grows faster than n cubed. So that means that as we go towards infinity, the numerator becomes way smaller than the denominator. And we know that when the numerator becomes smaller than the denominator, the limit approaches 0. So the answer to problem B is 0. Today we learned about sequence convergence in calculus. Thank you for watching this video.